Is the Ryobi power station something you need in your tool arsenal? Let's find out. This is the Ryobi 40 volt power station. Now this is the model number RYI1802BT. Now obviously this runs on the 40 volt lithium batteries from Ryobi, and it will run on just one battery. Now they recommend it to be at least 5 amp hour batteries, and they recommend at least 2 batteries, but it will run on a single 40 volt battery, and we'll show you that here in one moment. Now it has a spot for actually 4, but as I mentioned, it does not require 4, but they recommend 2, and it will run on 1. Now each of these ports are numbered, and when all of the batteries are in here and you plug this in, you actually have a plug-in where you can plug just the plug right there. It will charge all 4 of the batteries, not at once. It will charge one, then the next, then the next, then the next, but it will handle all of that from just plugging it in this one place. However, that is a very low voltage charger, and we'll take a look at that here in a few moments. Now, let's go over some of kind of the bare bones features, if you will, and then we'll kind of start talking about batteries and how much output we're going to get out of this, and get into the finer details, and then we'll actually use this and do some comparisons, and what you might run into when you're actually using this if you decide to buy it. Now in its strip form, it's actually very light, and we'll weigh that here in just one moment. It's just about a little over 13 inches tall. With the handles, you're about 12 inches wide, and then as far as length goes, a little over 17 inches long. So it's not that big, especially compared to, say, a gas generator. This is pretty small, as well as it's very light. So you can see with one hand and my arm stretched out, I can easily lift this up. Now, there's no batteries on here yet, so that's going to be a big difference. But let's go ahead and throw this thing on the scales while we've got it here. So you're looking at below 13 pounds, 12 pounds, 7 ounces, again, without any batteries on there. So without the batteries on, you could easily grab it with one hand. Even a child could grab it, throw it in the truck, throw it in the car, in the boat, wherever you're going to put this, and easily transport this. Now let's throw 4 of the 6 amp hour batteries on here. You can get this in a kit with 2 6 amp hour batteries. And so I thought, you know what, we'll go ahead and throw 4 6 amp hour batteries on here, and then get a weight on it that way as well. And we're looking at 29 pounds, 14 ounces. So almost 30 pounds, right at 30 pounds with the 4 6 amp hour batteries on here and the actual power station. But you can see with the 6 amp hour batteries, we still don't expand outside of our handles here. So still the same size unit, even with all 4 batteries in tote. Now, in addition to these handles sticking out, they also act as somewhat of a roll cage. So I can sit this on the side and it's resting on the handles and not actually on the batteries. So if it gets tumbled over, no big deal. This kind of cage is still going to protect it and act as handles. And you also get some spots here, like right here, where we can wrap around an extension cord all the way around the unit and keep that tucked away and nice and wrapped up, as well as there's even a couple of places up here where you can actually put that extension cord or kind of clamp that in, if you will. Now let's go over everything here on the face of the unit. Obviously, we've got an LCD screen. We'll turn that on here in a moment. There's a small LED light right here on the front. You can kind of use it as a work light or just kind of an indicator light. I got a couple of USB Type-C ports, and these are actually 3 amp out. So you get 3 amp out on the USB Type-C, and then we get 4 USB Type-A ports, and those are going to be capped at 2.1 amps out and 5 volts DC. And then we have a power button to power the unit on, and then a power button to actually power on the 120 volt outlets right here. Now these say 120 volts at 15 amps. We'll dig into the details of those here in one moment. And these are also, as it states right here, ungrounded outlets. Even though it has the place for the ground, they are ungrounded outlets. We get a couple of buttons here that will show kind of what those control. And then we have 2 ports right here that says parallel. Now The idea here is you can actually daisy chain these generators together. So you can buy an adapter cord that I think it's like $50, and you can actually tie two of these together and basically double up your power and provide more power to your RV or whatever you're trying to power tools, what have you. Then we have a circuit breaker right here, so if that pops, then we can just push and reset the circuit breaker. Now, as I power this up, the stats on this machine are basically, there's three big numbers we need to talk about. There's the big number, 3,000 watts. So what does the 3,000 watts represent? Well, that's kind of startup power. So take an air conditioner when it first starts up, or a refrigerator, that compressor has to start up, and it takes a lot of oomph to start it up, and then it kind of ramps down and can run on a lot less power. So that's the idea with the 3,000, is kind of a sudden surge, and then it backs out. If it's needing that constant, it's not going to put out 3,000 constant watts. Now, there's also an 1800 number. And what does that mean? Well, the 1800 is a 3-minute continuous runtime. So in other words, it will push out those 1800 watts for up to 3 minutes, and then it needs to, again, kind of cycle down. And the 1600 number is pretty much the true number on what the output on this is going to be. And that's 1600 watts out continuously. So with 4 decent batteries on here, or even just a couple of batteries, we should be able to see 1600 continuous watts out on this Ryobi power station. That's pretty cool, as you can see here on the screen. So now we've got our LCD screen lit up as I held this button and powered it on. And by the way, I have to power up number 1 and then power up number 2. And I can shut off the outlet. So I can have the unit powered up and have the outlet shut off where it's not pushing anything out. Even if something's plugged into there, we have to have that turned on. So I can separately turn that on and off. And also, one of the cool things about this is that Ryobi also has an app. And from the Gen Control app, which by the way will work with some of their gas-powered generators as well, now I can see any output. I can see my battery status level. When we use it here in a moment, we'll actually see the watts that are going out. I can even control things. I can turn this on, as you see. I can turn the AC power on and turn the AC power off right there from my app. So pretty cool. I can also turn this light on. So this light I can turn on from right here. So I get a high, low, and then a red blinking. I can do the same thing from here. I can go right in here and go into settings and LCD backlight. And I can turn that on high and low. So right there from my app, I can also turn it off. So that's the backlight. And I can also go into the task light, and I can tell it to turn it on, and then go to blinking red. So I can tell it to blink red, and then I can just tell it to go back to low, and then even to high. And then I'll turn that off. So right there from my app, I can do that. I can even power down this machine, but the problem with doing that is once I shut it down, I can't turn it back on from my app. So you can see here, press and hold yes to confirm. So if you were inside and want to turn this off because it was sitting outside, you can hold that down for a few seconds and it's going to power down this machine. Now the problem with that is I can't turn that back on with the app. Now I have to go back to the machine and actually power this back on, and then I can tell this to scan again and look for that Bluetooth device, look for this power station, and it'll find it again. Reconnection, and there we go. It's now found it again. So pretty cool. I can see the status of the batteries. I can see what's going on, pushing out. I can control lights. So pretty cool idea to be able to see that as long as you're within 50 feet or so of this unit. It is a Bluetooth connection. It's not a wireless connection, but we can do some things as well as keep track of what's going on our generator or on our power station. Now we talked about some obvious numbers. Now let's talk about some not so obvious numbers. And actually I kind of found some things that kind of stuck out to me, and so I wanted to dig in and see what was going on. So I actually read the manual. Imagine that. I rarely do that, especially when it comes to power tools. I just usually pick them up, start using them, and then if I have an issue, I dig in. And by the way, in this manual, it gives you some great insight into using even a generator on kind of what things consume, what type of, talking about amps and voltage and watts and motor sizes. So if you've got a fan motor or some type of electric motor that's a 1 horsepower, it will tell you how many running watts that typically takes, how many startup watts it takes, and so forth. And then, so here's where I got to. I got to the feature section. And noticed that on the rated AC output, it says 120 volts AC, 60 hertz. By the way, this is pure sine as well. So we get a pure sine signal as far as the output. So our sensitive electronics, no problem with charging our laptops, our phones, things like that. It's not going to hurt that because this is pure sine. So any questions on that? Hopefully that answers it. But anyway, we said here 120 volts AC, 15 amp, like a typical 15 amp outlet. Well, if you actually dig in right here, rated AC output, 120 volts AC, 60 hertz, 13.3 amps. So it's not actually 15 amps, it's 13.3. Is that a big deal? Probably not, unless you're going to be running maybe a big saw or something that's going to draw actually 15 amps, then you're going to have a problem. Now, what it does say is it will do 15 amps for up to 3 minutes, which equates to, again, that 1,800 watts out for 3 minutes, because you take 1,800 divided by 120, that should give you about 15, which is your 15 amps, because we know that amps times volts equals watts. And we'll go over that here in one moment as well. And then another one, here's our rated output, like I was talking about. There's our 1,800 or 1,600 watts, 1,800 watts for 3 minutes, and 3,000 watts starting watts. So again, that tells us we can kind of instantaneous hit 3,000, but if it's anything more than that, we're going to have an issue. And then 1,800 watts sustained for a few minutes, and then it needs to kind of ramp back down to that 1,600 watts. So again, there is some decent insight in this Ryobi manual. Again, usually power tool manuals kind of get discarded right away, but there is some useful information in here. If you buy one of these, look through it. Great intel. Okay, we're about to power this up and use it, but before we do, let's have a small discussion on batteries. Now, this power station is powered by batteries. Right, Tim? We know there's batteries on the side. We get it. But there's no pixie dust in here. There's no fairy dust. There's no miracles happening in here that makes these batteries be able to power other batteries or power other things with less consumption or anything like that. It just, what's in here goes out, and once it goes out, it needs to be replenished somehow by a power source. So just understand that. So how much power is actually in these packs? Well, let's talk about that. So if I take off this 6 amp hour unit, you'd probably go, Tim, I know this, I know, I understand watt hours, understand watts, so stay with me here for a second. Let's take a look at this. So let's take a look at a very simple equation, that is volts times amps equals watts, okay? What do I mean by that? Well, let's take 120 volts times 15 amps, which that's what a typical circuit breaker trips at. And that's going to give us, so we got 120 times 10, that's going to be 1,200, and then 5 times 120, which will be half of that, so you're looking at 600, so 600 plus 1,200 equals 1,800 watts. Sorry about the math in my head, that's just how I get there. So 1,800 watts, that's what basically will come out of that outlet. Well, then you talk about 13.2, blah, blah, blah. Anyway, but let's just understand that volts times amps equals watts. Well, let's take a look at this battery. And I know what you're going to say. We're going to talk about watt hours, and you're going to say, I know how to do this, Tim. We're going to take 40 volts, and we're going to multiply times the 6 amp hours, and that's going to give us 6 times 40 is 240 watt hours. And that's how we measure a lot of batteries, is by watt hours. Well, you would be right if this were 40 volts, but we can't look at it that way. Because if we look here on the battery, it says 216 watt hours on a 6.0 amp hour battery. Well, if they're doubling down on the 6.0 amp hour and they're telling us 216 watt hours, why is that not equating? Why aren't we 240 watt hours? Well, I'll explain to you. Number one, 40 volts. We only get to 40 volts kind of under max charge. Same way if you look at a DeWalt 20 volt, anything 20 volt max, that's because when you first take it off the charger and you measure it, you're going to get 20 volts. When you first take this off the charger and measure it, you're going to get 40 volts. However, the nominal voltage is 36 volts. So if we take 36 times 6, that equals 216 watt hours. So understand that when you're looking at batteries, always look at your watt hours. That's going to give you the true idea of what kind of power is stored in that battery. So are they lying by saying 40 volts? No, they're not at all. So they're not trying to pull our legs or anything else. But when you start digging into the nitty gritty, you got to look and see what kind of watt hours we're getting out of there. And that's going to be your voltage times your amp hour is going to be your watt hour, or take your watt hours and back into this. So these numbers here are going to help us in basically all that we do with this power station. So while we're here, let's take that 216 number, 216 watt hours, and let's multiply that times 4, because that's how many of these 6 amp hour batteries we have on here. And so if we take 4 times a 200, that's going to give us 800. And if we take 4 times 10, that's 40, and 24, 64. So 864 watt hours. Now, what does that tell us? Well, let's look at a watt hour. What is a watt hour? Well, watt hour is basically the consumption of 1 watt for 1 hour. So you're saying, well, Tim, does that mean that I can run something that takes 864 volts or 864 watts and run it for 1 hour? That's exactly what I'm telling you. So if you're running something with, say, 1600 watts, you're going to run that for about a half hour, maybe a little less than that. So again, no magic or pixie dust in the power station here. It is what it is. If you have something that's consuming watts, it's going to consume those batteries, and there's no magic that's going to make those last infinitely longer. So we're about to use this, but by the way, they also have a bag that comes with the unit that you can actually put over this, with actually has a clear front on it where you can see the screen and everything else. So pretty cool. So if it's drizzling out or something like that, that will keep that from getting wet, and that comes with the power station. Now to show this in use, I have a pretty cool little setup here that actually has a bunch of halogen bulbs on here. And you know, used to most of your job site lighting were halogen bulbs, and they get really hot and they consume a lot of power. Now on this one, I've actually got several different switches here. In fact, there are 10 different switches that control different amounts of these bulbs. And in fact, each one is 500 watts. And I can call on, with this switch, it'll call on 2 of them, which is 1,000 watts. And then I've removed a bulb out of here. So one switch is going to pull on another 500. And then another switch is going to do another 1,000, and another switch another 500, and so on. So we can do 1,000 or 500 increments and power this up. So if our continuous is 1,600, then basically I can flip 2 of these on, and then another one is definitely going to overdraw the circuit. Now to keep things hunky-dory, if you will, I also have these circuits split into different ones. So I'm not going to overpower everything. So I'm going to plug in the number 1 here. And let's turn off all our switches. All our switches are off. And then I'm going to plug in the number 2. And we'll plug in our number 3 as well. Okay, so we've got all our switches off. Let's go ahead and power up our outlets. So now we've got our outlets powered up. And let's also pull up our app on our phone here. And that's going to help us basically see these watts out, if you will. So let's go ahead and power one up. By the way, you can see that all 4 of these batteries are charged. Load level is at 0%. Let me see if I can turn that LCD screen. There, a little brighter. Maybe that helps. So our load level still is at 0. We're going to turn 1,000 on. So you can see there. Now we're at 62% load level just off of that one switch. You see we've got 1,019 watts out. And we've got a smoking halogen light. So you see just off this flip of one switch, turning on 2 500 watt lamps, which by the way is very close because it looks like we've got 1,000 watts out, and again 62%. Now let's throw on the second switch, which should throw on just one more light, and see where it gets to here. Now we're at 1,481 watts out. We're at 91% of our load. Now let's see what happens. I'm going to just call on another 500 watts. And now we're going to 100%, and it's actually going over to that 1,874. And now let's see how long this lasts. Oh, it just kicked off. So once it went to that 1874, it didn't last but probably 15 seconds, and it overloaded the circuit. Let me kill these switches. And I'll say okay. And by the way, right here, I can reset this from my app. I can do it here and hold that button, or I can just hit reset right there. And this is going to reset the unit. Now, if you heard something come on, there's a fan on the back of this, which once you start building up some heat, that's something else. You know, off of these batteries, not only is it kind of a one-to-one out as for what you're powering, but also you are going to be running a fan, which granted, it is a small micro PC type of fan, and so it's not going to draw a lot of current, as well as you're going to be powering the screen here, which again is not going to draw a lot of current, but you are consuming some other electricity or some other power outside of just what you're feeding to your grid here. So let's go back in and let's flip a switch here. In fact, let's just call 500 on here, and let's call 500 on, or 500 on 3 and 500 on 2. So now we should be, yeah, we're drawing right at 1,442, so right at 1,500, and we're at 88% at capacity. Now the interesting thing is, again, if I call on, let me turn one of these off and call on the other 1,000 here. We're going to go over again, we should. So 1,817, let's see if it'll hold that for very long. At about 10 seconds right now. Nope. So it's not holding that 1,800 watts. Granted, we were over just a little bit, but it's definitely not holding that for very long. It feels like that 1,600 number is really the one that we need to be set at. Now I'm going to go ahead and power down this machine. And I'll show you why here in one moment. Okay, we've got it powered down. And now I'm going to power it back up. And what I'm going to do is I'm going to go ahead and throw on about 1,500 watts. And let's see how long it will run to consume any of the battery. We may not bring it all the way down, but we'll run it a few minutes to actually see. And so we've got our counter clicking here. And let's call on our AC power. So we've got our AC power on now. And now let's call on a couple of lights. So that should be about 1,500 watts. Yep, 1,511 watts, 93%. Now let's run that. So we've got our ticker ticking at like 37 seconds. So let's see how long this lasts before we start dropping some of the cells in the battery. Okay, I don't know if you noticed, but our lights were actually smoking while we were using it here and kind of doing this test. We ran it a little over 10 minutes, and as you can see, we dropped a cell on all 4 of the batteries. So that gives you an idea of kind of the power you're going to consume when you're running, in this case, 1,500 watts solid for 10 solid minutes. I think we started somewhere around the 30-second mark and went a little past 10 minutes. And again, if you didn't see it, our lights were smoking, and that's why I flipped a couple off and turned some others back on. But we kept that, 1,480, 1,500 watts, or at least 1,400 watts going for the complete time. And by the way, you can hear this fan starting to cycle down now. But anyway, so that's a decent runtime test of just 10 minutes of something that's drawing a lot of power is going to consume batteries. Now again, we only dropped a cell or so, but we did actually use some of that up. Now another question that gets asked a lot is, will it run a refrigerator and will it run a portable air conditioner? This is a portable, I believe it's a 1-ton air conditioner. Let's see here, somewhere on here it should tell us 10.8 amps and 3,520 watts. Oh yeah, 12,000 BTU. So that's this is a 1-ton air conditioner. So it says 10.8 amps out. So let's see here if we can power on this unit. Okay, we've got it plugged in. We've got our outlet on. Let's call on the AC. Looks like we're at 40%, 647 watts. So yeah, it powered that up with no problem at all. And it looks like it's running at about 61%. So it's toning down just a little bit, but kind of peaking out around 1,000 watts. So it did finally call on that compressor and running about 1,000 watts. So it's actually drawing a little less than the 10.8 amps that they said, because 1,000 divided by 120 is definitely not 10. That'd be somewhere around 1,200 watts. But anyway, still able to run this 1-ton AC, and it's blowing nice and cool out the top here. So now the question is, can we run our AC and still call on a few lights? You should be able to see some brightness change here. So we've got 1,100 watts, so right at 1098. That's continuing to ramp up just a small bit. So we're up to about 1,100 watts now. We may make it to that 10.8 amp output. Again, we're at 67%. So let's call on, let's bring on 500 watts of light. There we go. So now we're at 1589. 98%. So we're right at the peak. So let's see if we can run this. Again, I know we just ran all the lights at say 1,400, 1,500, but now we're running the AC and we're running the lights, and you can see we dropped another cell on our batteries there. So we've consumed about half. Continuing to stay at that 97, 98% of the load level. Okay, let me kill these lights and then we'll kill our AC. Should see those watts come down. So now we're at 0 watts. And you see our batteries picked back up as well. So here's the bottom line. You could ask me 500 ways to Sunday. Tim, will it charge this? Will it do this? Will it run this? Will it run that? And everything's going to be different. Look at what the draw is on whatever machine you're trying to run, whether it's an electric skillet, whether it's a skill saw, whether it's a drill, whatever it is. Look at how much power it consumes, or even test it, and then you're going to know how much juice you've got in your battery packs and how much juice is left in your power station as to how long it's going to run. And as I mentioned, this is actually a very useful manual, and there's some great charts in here that gives you an idea of how much draw and how much power different type of accessories and appliances and tools and what they consume. So great manual to keep. You can keep it, somewhere on your power station or in your bag. Anyway, good idea to keep that. Now, before we wrap this up, let's talk about batteries just for another second. And just wanted to point out that we were running all 4 of these 6 amp hour batteries, which is pretty interesting, because take a look at this 6 amp hour. And then take a look at this 8 amp hour. And you say, well, Tim, my goodness, how can that be? That 8 amp hour is smaller than that 6 amp hour. That is exactly right. Take a look at this 12 amp hour, and it's pretty much the exact same size as the 6 amp hour. So they're getting some higher density cells where they're able to pull more runtime and more power out of the same size cells. So that's how we've got a 12 amp hour that's the same size as the old 6 amp hour, and the 8 amp hour that's actually smaller than the 6 amp hour. Now these are not quite out yet. They should be coming out anytime soon from Ryobi, and you'll find them at Home Depot as well. So that would literally double your run time over your 6 amp hour, because you're just doubling your watt hour. So it is what it is. So whatever you're getting out of the 6s, you're going to double with the 12. So if you can afford it, if you want it, if you need it, then you're going to have the 12 amp hours to choose from as well. And then just one more thing, let's talk about chargers. This is the actual charger that comes with this unit. So you plug this into the wall, you take this little guy right here, and it plugs in right here, and then that charges all the batteries, not at once, but it will charge them each. As it charges, it'll charge one, then go to the next, just by plugging that in. So very convenient, but it's not very fast. And why I say that is because if you look here on the charger, it tells us 120 volts at 80 watts, and then let's look at the output. Output is 42 volts at 1.5 amps. So if we do our same calculation, 42 times 1.5, that's going to give us 63 watts. So we get a 63 watt charger here. Now let's compare that to this guy here, which is a rapid charger that charges 2 batteries. And if we look on the back here, it will tell us this OP409, 120 volts, 60 hertz, 590 watts. So a lot more power for charging those batteries with this dual port charger than with the one that plugs into here. Now, if you know you're somewhere and you just want to trickle charge it, if you will, because that's basically what this is doing, by all means do it. Now, at the same time, you have to understand, you cannot use this power station while it is charging. So once you plug this in, you no longer have access to actually use these outlets when it's charging. So it's either charging or it's outputting. You can't have both. Now, lots of complaints on that, but it is what it is. Just wanted to point that out to you. So it may make sense to you to have a separate charger where you're plugged in somewhere else, that you're actually charging this, and then take these and put them back on the power station. So let's get down to brass tacks. What's the cost on this guy? Well, you're looking at $849 for the power station and 2 6 amp hour batteries. So as you see right here, with 2 6 amp hour batteries and the power station, you're looking at $849. Also comes with a 5-year warranty on the power station. I believe the batteries are covered for 3 years, but I know the tool or the power station is covered for 5 years. Now here's something else. You can get this not really as a kit with 4 batteries. You get 2 more of the 6 amp hour batteries and the dual bay rapid charger for another, I believe, $400 something. So basically $1,340 for 4 of the 6 amp hour batteries and the power station and the dual bay rapid charger. Comes with the cover as well. So that's going to run you, again, about $1,340. So $849 the kit with 2 batteries, or $1,340 for the kit with the 2 batteries and 2 more batteries and the dual bay charger. Again, covered for 5 years on the tool. Let us know your thoughts. I definitely think you need to stay at that 1600 watt range. If you're pushing that 1800 or even trying to hit that 3000, I don't think you're going to be happy with this machine. I think it's a great idea, but again, just understand, power in, power out. There's no, again, as I mentioned, kind of no wizards or fairies inside of here doing any kind of magic. It is what it is. You're only going to get so much power out of these battery packs, as well as so much power at one time out of this machine. It is a great idea. If you wanted to run parallel and run 2 of these machines and get double the output, you can definitely do that. So be sure to check it out. It's the Ryobi 40-volt power station. Also keep track of us on Instagram, Facebook, and Twitter. Also TikTok. And if you don't mind, hit that like and subscribe button if you haven't done so already. And by all means, if you hated our video, then give us that thumbs down, but let us know in the comments why. Have a great day and keep smiling.